Yeah, welcome guys again. I'm Hyper. I'm taking you through homogeneous differential equations. And with homogeneous differential equations, we are saying that if the degree of the individual terms in the differential equation is the same and constant, then the differential is said to be homogeneous. We are going to look at these examples and maybe get to know if the degree of the individual terms is the same. Here we have x, meaning degree 1, y degree 1, x degree 1. So this is first order. Homo means the same. Yeah. This is first order. You have x squared, second order. Y squared, degree 2. Xy, this one constitutes degree 1 plus degree 1, which is degree 2 also. So this is second order because the highest degree of the derivative is 2. Then if you look at this, x2, x squared, degree 2, x squared, y squared, xy also constitute degree 2. So making this one also second order. When you look at the third one, we have t cubed, that is degree 3, t cubed, theta, t cubed theta. This is degree 2 plus degree 1, making it degree 3. T theta squared. This is degree 2 plus degree 1, which is 3. T cubed 3. So making this one third order. So when you have these kinds of differential equations where the degree is the same, now we don't use any of the methods we've looked at, but instead we solve them using by substitutions. Y is equals to ux, or y is equals to vx, or y is equals to zx, whichever, which transforms them into separable differential equations, and then we go separate variables, then we solve these equations. Without wasting any single minute, let me look at examples. Basically, examples, I'll do 4 of them or 3 of them, then I let you practice. Examples number 1, use substitution y is equals to vx to solve the equation x squared dy dx is equal to x squared plus y squared plus xy, given that x is equals to a quarter pi when y is equal to 0. Now you need to first really see that this is homogeneous. How? You have x squared, that is degree 2. You have x squared, degree 2. Y squared, degree 2. Xy, because they are being multiplied, means degree 1 plus degree 1, which makes degree 2, making it homogeneous. After having known that the equation is homogeneous, they say that use this. Y is equals to Vx. So we shall say y is equals to Vx. We need to know what dy dx is equal to. Dy dx, since this is a product of two quantities v and x, we shall use product rule. So when we are using product rule, we hold x, this is like our v, this is our u. So we hold x, we differentiate v. So x dv dx plus we hold x, we hold v, we differentiate x. So plus v, when you differentiate x, you get 1. This is by product rule. I've done that by product rule, which I do believe that you know. Now, after getting this, then now we shall substitute into this equation. So substitute, it would mean that we substitute, we shall have x squared, but instead of writing dy dx, we shall write this x dv dx plus v is equal to x squared plus xy. So I'll write x, yeah, I write x. Then instead of writing y, I'll write Vx. So it will be Vx. Well, implying that here you can divide through by x squared. So we shall have x dv dx x dv dx plus v is equal to, we divide by x squared, so it will be 1 here, plus, if you divide, oh, I forgot y squared also here. I forgot y squared, so it will be y squared, which will be v squared x squared. So this is vx squared, so we shall have v plus v squared. So that is what we are having. Now, here, you see that this v and this v will cancel. So we shall have x, the v by the x is equal to 1 plus v squared. And now this one has become separable. So we are going to separate the variables here. When you separate the variables, multiply by dx both sides. So we shall have x dv is equal to 1 plus v squared dx. I've multiplied dx both sides. So when you separate that, we shall have dv out of, bring the ones of v, so it will be 1 plus v squared is equal to dx over x, yeah, dx out of x. The second step here is to integrate. If we integrate dv over 1 plus v squared is equal to the integral of dx out of x. Now, members, this is tan substitution, because when you differentiate the denominator, you don't get the numerator. So this is tan substitution, 1 plus v squared. So this is the same as tan inverse of v. I say, members, in case you are very confused, I recorded a video about tan substitution and sine substitution. So this is tan inverse of v is equal to, when you integrate dx over x, you get ln x, then plus a constant of integration. Yeah, ln x plus a constant of integration. Now, but v here, we don't need v anywhere. V is the same as y over x. So it means that here we shall have tan inverse of y over x is equal to ln x plus a constant of integration. Substitute. They say that when y is 0, x is a quarter pi. So when y is 0, x is a quarter pi. So if you substitute here, we shall get tan inverse of y0 over a quarter pi. Yeah, so the whole of this, call it tan inverse of 0, is equal to ln, yeah, a quarter pi plus a constant c. So now it means that our c, tan inverse of 0 is 0, so it will be negative ln a quarter pi. Now we shall substitute this value of c here. So we shall say that tan inverse of y over x is equal to ln x, then plus c, which is minus ln a quarter pi. Now, this is tan inverse of y over x. I told you that ln behaves as logarithm. So it is x, it will be ln, a single ln x over 4 pi. ln x over 4 pi, I guess, yeah, because this is ln x minus a quarter pi, meaning it will be x divided by pi over 4, yeah, which is x divided by pi over 4, the reciprocal will be 4x over pi. Very smart. Then now, we need to eliminate the tan inverse this side. It means that y over x is equal to tan inverse, yeah, it will be the same as tan inverse of no. Actually, when you bring the tan, when you eliminate the inverse, it will be, it's like when you have tan theta is equals to 0.2. So theta is tan inverse of 0.2. So even here, it will be y over x will be equaling to tan 4x over pi, implying that y is equal to x tan ln, I forgot ln, tan x tan ln 4x out of pi. So that is how we do it. That's how we do it. Number two, solve x dy dx is equal to 2y. This is homogeneous. They have not told you what to let. I just say let u or let y is equals to ux, implying that dy dx is equal to, you will use product rule. First hold the v constant, differentiate u, so du dx plus hold u, differentiate v, which is 1. So this is it. Then now it means that wherever there is u, you'll be substituting y over x. So substitute this into this. So we shall have x dy dx will be x du dx plus u is equal to 2y. So 2 ux. Implying that if you divide by x here and here, you have x du dx plus u is equal to 2u. Or one can write and say that x du dx is equal to u, because it will be 2u minus u, which is u. Now implying that here you can now solve the differential equation by separating variables. So we shall say du over u is equal to, dx will have come this side, so dx over x. Integrate both sides. D over u is ln u. Dx over x is ln x. Then plus a constant of integration. So with this case now, it is going to be ln, but u would be y over x. So ln y over x is equal to ln x plus c. Yeah. So from this case, here, one can leave it here, or or if you can reach after reaching here, one can stop it at this point. Yeah, one can stop it at this point, or here one can have ln u from here is equals to ln x plus plus a constant. See here, so it means that one can say ln u is equals to ln x plus this constant, even it can be ln a. I can say where ln a is a constant because it has not changed any meaning, implying that ln u is equals to ln ax. Now, if it is ln ax, it would mean that yeah, it would mean that here it would be ln u, but remember my u, it means if ln u is equals to ln ax, then u is equals to ax. That is what it means. So implying that u is equals to ax. So if u is equals to ax, then it would mean that y over x, which is u, yeah, y over x, which is u, is equals to ax, meaning that y is equals to x squared. As simple as that. So one can move it up to this side, and here you can make me very happy. You can make me very, very, very happy. Allow me to do the last one. I give you two numbers to do, and let me see. Number 3, sort of. Using substitution y is equals to vx. This is my last question, and it seems a bit tricky. But let me struggle with it, and then I give you an exercise to do. Solution, we know that if y is equals to vx, then we have said that dy dx is equal to v plus x dv dx. This is by product rule. This has to be the first step, implying that y dy dx to x minus y, yeah, it would mean that this one will be the same as where y is, we shall put vx, so vx dy dx dv dx this is going to be equal to 2x minus y, which is vx. So this is, if you divide through by x, it will cancel. You divide here by x, you divide here by x, you divide here by x, so we shall have v squared plus vx dv dx is equal to 2 minus v this side. So it would mean that vx dv dx is going to be equaling to 2 minus v squared. Yeah. Implying that vx dv dx is going to be equal to, this is the difference of 2, actually this is the same as 2 minus v squared is the same as 1 minus v into v plus 2. Yeah, you can as well put on the calculator so that gives you factors of this equation, and then you put there. So it would mean that after having gotten this equation, we are having vx dv dx is equal to this. So now I want to separate the variables. First, multiply dx throughout. So we shall have vx dv is equal to 1 minus v plus 2, then dx. But we want to separate variables. So the ones of x, you bring them here, then the ones of v, you bring them here. So when you separate the variables, it will be v dv over 1 minus v plus 2 is equal to dx over x. And this is followed by integration. But as you can see, this one is a partial fraction. So we shall first let v over 1 minus v plus 2 be equal to a 1 minus v plus b over v plus 2. These are partial fractions. So here you can solve for the values of b. It means that v is equal to a into v plus 2 plus b into 1 minus v. So here you can solve for the value of a and b. So we can put, if we put v is equals to -2, it will give us b as -2/3. And if we put v as 1, it will give us a as 1/3. So that one, at least I know we have gone through it very well, and partial fractions, so it shouldn't be something very tricky for you. Okay, so after having gotten this, we are going to therefore say that our v over 1 minus v and v plus 2 is the same as a, which was 1/3, so it will be 1/3, 1 minus v. Then the value of b was -2/3, so minus 2/3 of v plus 2. Now, it would imply that the integral, because we were in the point where we're going to integrate, the integral v out of 1 minus v, yeah, then v plus 2, yeah, dv is going to be equal to 1/3 integral of 1 over 1 minus v dv, then minus 2/3 integral of 1 over v plus 2 dv. And this should be equal to the other side, the right hand side, the integral of 1 over x dx. Yeah, so this is negative, this is 1/3, but being 1 minus v, when you integrate this one, you get -1, which is not 1. So it will be negative a third ln 1 minus v. Yeah, then this will is automatically minus 2/3 ln v plus 2 is equal to, when you differentiate 1 over x, you get, when you integrate, ln x plus a constant of integration. So it means that a third, negative a third ln 1 minus v. This one being this one here, I would say negative a third ln 1 minus v. Then this one here, a third, actually, I put a third out. A third is out. A third is out. So I will just say v plus 2. Then squared. This 2 has come this side. Then this is equal to ln x plus a constant c, implying that ln 1 minus v times v plus 2 squared is the same as ln, this 3, bring it this side, so it will be ln a x power negative 3, where that a is equals to c. A is equal to c. So this 3 came this side, negative. This 3 came this side, so that's why I'm having ln ax power negative 3. It means that this negative 3 powered here, but then this is like ln a. So when you're adding, of course, you have to combine them. Ln ax power negative 3, implying that x power negative 3 1 minus v, then v plus 2 squared is the same as a. So this one will bring you to x minus y, then you have to substitute for v, then y plus 2x squared is equal to a. That is why you have to substitute your y as vx. So from here you can simplify the thing and simplify that thing your own way. So when you expand this, you come up with 4x cubed minus 3xy squared, then minus y cubed is equals to a. And that would be my final answer. You shouldn't be too much surprised here. First, I factorized out a third. Do the same, factorize out a third. We factorize out negative a third, sorry. Factorize out negative a third. It means that here you have ln 1 minus v plus 2, because this negative is already out. So plus 2 into, actually it is 2 ln v plus 2. That's why this 2 came here. And when the 2 came here, so now it means that I have negative a third into ln 1 minus v plus 2, everything squared. That is why I have this step. Then continue simplifying. So that is what I can do for you. Let me give you the exercise, which I do believe you are going to pass. Which I do believe you are going to pass. Exercise number 1. I want you to solve xy dy dx is equal to y squared plus x square root x squared plus y squared. 2, I want you to solve 2 dy dx is equal to y over x plus y squared over x squared using substitution y is equals to xz let's phrase it like this. Using substitution y is equals to xz, show that, first begin with this. Using this, show that the solution of this equation is given by y minus x squared over xy squared is equals to a constant. Yeah, so all the forms we have exhausted all the forms, and since we have exhausted all the forms, yeah, what is just left now is to exhaust the applications. Are we sure that best? Yes.